All right, we're going to dive back in. It's the second time I've had to record this particular video. It turns out that I only had 4 kilobytes of hard drive space left. I'm sure you're asking yourself, how's that possible? Well, lots of RAM, 16 gigs of RAM in this computer, pretty awesome processor. But before I started doing the series, my hard drive crashed, and I'm kind of lazy and didn't want to go out and buy a new one. Haven't really ordered one yet. So what I did is I pulled out a solid state drive that I had, slimmed it to 60 gigs, put Windows on that. And so I got some games, Steam, some other things. I have .NET 4.0 framework installed. That's like 4 gigs. Anyway, long story short, I had all of that video stuff sitting on there. I was chewing up tons of memory. I wasn't paying attention. We got down there, recorded the video, tried to save it, didn't, lost it, so I'm redoing it. So in the last video, we left off basically talking about how pointers being used incorrectly can cause undefined behavior, and sort of talking about the general concept of a pointer, and how on the surface, maybe when you first sort of explain it to people, they'll say, oh well, that's not such a complicated thing, what's the big deal. We're gonna sort of try and illustrate that a little bit now with Cheat Engine. We open up the game. Doesn't matter. We're not gonna change anything. We're just gonna attach to it. Nope, we don't want to do that. We're gonna open up Cheat Engine. Yep. Attach to Shadowrun. All right. So in one of the previous videos, what we were doing, we were clicking here and we were saying, oh, we're going to crash the application. We're going to fiddle around, screw around, be funny for a little bit. We were typing some values in here. We were getting some values over here. No idea what these addresses or these locations meant, but we were doing it to prove a point, and we're going to kind of do the same thing now to prove a similar point. So we're going to do this. What are we doing? We've talked about what we're doing before. This is the name of the process. There is some absolute value in RAM that this process is loaded at. This is essentially an alias for that, and then as we add offsets and things like that, we're going to sort of be indexing is a technical term. We're going to be indexing into the memory associated with this process. Now, how are we going to do that? Well, the way that we're going to do that is by using pointers here. We're going to add some offsets. We're not going to add offsets yet. We're going to bring up a calculator. We're going to talk about some hexadecimal stuff, some hexadecimal values. We're going to use them. We're not going to jump in and explain the whole concept because I don't want to derail the video. I want to basically re-record what I had so that we can get to a certain point, and then then we can I'll make a new video. We can sort of jump into hexadecimal as an A side, but we're still going over basic conceptual issues. I don't encourage anyone, or let me be more adamant than that. I absolutely would not encourage anyone to do stuff like this. We're doing this purely for illustration purposes to sort of prove the point that it's a simple, or pointers as a simple concept, not hard to understand, but when you start stringing them together, multi-level pointers, multiple offsets, things like that, rapidly it's going to spiral out of control in relatively quick fashion, and there's no way of knowing, what there's no way of knowing whether we're off by one or whatever. I mean, obviously, in more controlled circumstances, there's ways of knowing that, and we'll certainly see that when we get into finding pointers and things like that. But we're still going over pointers in general. So what are we going to do with the calculator? Well, we're going to have to do a little math here to prove a little point. So what's the point that we're going to prove? Well, what we've been saying is, or what we have put forth the idea. We maybe hide that. We cannot. So we'll move this over here. We have been sort of putting forth the idea that a pointer is a variable and has a memory that's a variable just like any other, except the value of a pointer points to another location in memory, so that or points to another location in memory and or another variable or some value in memory, by its memory location. So if this is true, then we can create a point. We can just tell Cheat Engine, just basically what we're doing with this menu right here is we're telling Cheat Engine we're going to manufacture a pointer on the fly. We don't know really what the offsets are. We're just going to start fiddling around, pointing to different things in memory and see what happens. So right now we just have this pasted in. This is some absolute address in memory. We don't care what it is, but for our purposes, it's just that's the string the text that we're going to use to refer to that location. Cheat Engine totally on board with that. So what do we got here? We notice that this number right here, this is giving us some memory location. We go up here, it's the same. We go over here, it's the same. Let's add 4, because that's sort of the step, if you will, for offsets. We even make that 5. Yeah, I suppose we could if we really wanted to, but we don't want to do that. Just gonna do 4. So this is still the same. This is still the same. It's performing an additional, or performing an arithmetic operation right here. It's taking this hex value. It's adding 4 in hex onto that. What is it getting? It's getting 905A51. So can we prove that, again, if our logic for a pointer is correct, then it should be looking in this value, or this memory location, digging out a value, and saying, I'm sorry, it should be looking in this memory location, digging out a value, and then adding 4 to whatever that value down here is, and then it should be coming up with a new value. The left side here should not be related to the right side, but let's see, we can tell whether it is or it is not by sort of messing with the offset here, and we can see that it's 51 on the end here. We're hitting this, we're adding 8 onto this value now, so now we're up to 55. There does appear to be some correlation, and as a matter of fact, we're in decimal here in this calculator, so we got to change it over to hex. So what are we doing? 0905A4D. What are we doing? Well, we're adding 4 to that. So plus 4, enter. What do we get? A51, A51. Clearly, we are mistaken. Now, what's going on here? What's going on here is that this is, right now, we're just talking about one location in memory, and the value of that location in memory, Shadowrun.exe, is some 4-byte bit pattern, and the value of that 4-byte bit pattern is this in hexadecimal. It is going to that memory address in memory, and then we're saying, well, add 4 to it, and then it's, whatnot's doing that. So what we're going to do is we're going to add an offset. You can see immediately we'll do that one more time. There is a relation between what's on the left side and on the right side. We're going to add an offset, and you can immediately see that what we're getting up here does not in any way, appear to be related to the hex value that we have over here. So there is no world in existence where you can add 4 to 905A4D and then come out with D47B24. That is not valid. So what's going on here? Why is there no correlation? There's no correlation because the bit pattern in this memory location right here is this, and then we're adding another pointer. We're saying that this is a multiple levels of pointers here. So we have a pointer. It's pointing it to a pointer itself. What's the value what's the memory location of this pointer? It is 905A4D plus 4, which is some location in memory, as it turns out, it is 905A51. Then what's it doing? How come there's no correlation between these two values? What is this value over here on the right? What this value over here on the right is it's the bit pattern of the memory location as determined by this hexadecimal calculation right here, interpreted as a 4-byte memory address that we are then going to, in this last offset, we are adding 0 currently onto it, and we are getting some other value over here. Now you can see there is a subtle indirect way that Cheat Engine is telling us that there's 2 levels of pointers, and that is the little hyphen in the arrow. So we can just use the text box here. What that is, that's a hyphen, then it's an arrow. Is that a hard and fast universal thing in computer science? No. But that in general, when you see a hyphen and then a little right arrow, as the case may be, that is a sign in computer science. There's certain technical reasons why it's not important, but basically that's sort of a nondescript way of saying this is not an absolute value. I'm not just digging it out. What I'm doing is I'm messing around with pointers, and I'm digging up a bit pattern. I'm interpreting that as a location, and then I'm going to that location. I'm digging out the value of the the memory that I'm pointing to. So, are we totally on board with this concept? It's possible that we are not. Why are we even doing this? Well, because when you explain the concept of a pointer to people in general, they're like, this is bullshit. I don't know why everybody's making such a big deal out of it. And right here, we are doing a non-complicated pointer, multi-level pointer, and we're one offset really, and already we're starting to get into territory where okay, there's an address here, there's a bit pattern behind the scenes, there's a bit pattern in this address. What is that bit pattern? Well, it's a 4-byte memory location. We go to that 4-byte memory location. We add 4 in hex onto that, and then what do we get in the bit pattern of that memory? Well, we get this bit pattern here, and then up here we're saying, well, okay, we're at that memory address now. We're going to add 0. What's the value? The value is this, because this last offset, this top level offset in the context of the interface for Cheat Engine, this is not a pointer, as evidenced by the equal sign. This is just Cheat Engine telling us, here's where you are, here's what you're adding, here's the value. And we can see that when we add 4, when we bring this top offset up to 4, what it's going to do is it's going to add 4 onto this, not as a pointer, just as a value. It's a constant value. And this is going to turn into 28. So let's do that. Click. That's 28. This is plus 4. We can double check it. D47B24. If I can type right, D47B24. Just on a side note, D47B24, best rap group ever. Plus 4, enter. D47B28. We could hit 4 again. This will probably go to 32, or no, go to 2C because I'm retarded. We'll get into why I'm retarded in a minute. There we go, 2C. Yep, because there is no, it's not base 10. So, how is there a limit to the craziness that we can get involved in here? Absolutely not. Let's what do we got? 1, 2, 3, 4, 5. Yeah, let's do that. So what do we got here? There's again some memory location, some bit pattern that we're interpreting as a 4-byte memory location. We go there, we add 4 to that, we get this bit pattern, or this bit pattern as a new memory location. We go here. What are we getting? We're getting some. We're adding 8 onto this. What are we getting? Cheat is all zeros right here. Is basically saying that as a pointer, there's no way this is not valid. This is not a valid pointer. This is just some. Whenever you see all zeros right here and you're messing around with pointers, it's just as bad as seeing all question marks. For all intents and purposes, that is not valid. Let's play around with the second offset here. See what we can get. Can we get anything? I don't want to mess around with the offset. I don't want to get them too high, so we'll fiddle around with the bottom one first. And we get nothing. Screw around like this. See what we get. There we go. So we got some bit pattern that Cheat Engine is saying, yep, I can, is it checking to see if this is a valid memory location? No. It's simply saying there's a value right here. I'm digging out the bit pattern, in this case 32 bits, digging out the 32 bits associated with this location in memory, translating that into some memory location, and then you're telling me that you want to start indexing even more with pointers. I'm not doing any sanity checking. You're totally in control, and if you screw up, crash programs, that's not Cheat Engine's fault. It's always the fault of the user. From this point on, that is what we're going to say. Cheat Engine will always do what we tell it. If there's a problem, Cheat Engine is more or less never going to be at fault, especially when we're dealing with pointers. It is always our fault as the user. So we are totally in control here, and if we screw up and crash programs, it's all on us. So what's going on here? Well, bit pattern, memory location, put that back up here, add the offset of 8 to it. We get some other value. This is getting way the hell out there in memory. So what do we got here? We got some other memory location. Let's go up here. We're gonna fiddle around here. We're gonna see if we can get all the way up to the top level. I doubt we'll be able to. I highly doubt we'll be able to, frankly. But we'll give it the old college try here. There's one level deeper. So we fiddle around with this a little bit. See if we can get some value in the one above us. Nope. Anything else? Anyone? That's definitely not what we want to do. I don't know. This is, again, don't ever do this. We're just proving the point that multiple levels of indirection, as far as pointers go, rapidly devolves into complicated stuff that's very hard to understand. So anyway, I'm not really gonna screw around with that anymore. We'll go back and go over this in much greater detail, but the point of this video has been to illustrate that pointers as a concept is a relatively generic concept. People first hear it. There's I don't know what the big deal is. What's so powerful about this idea? Why is it so complicated? We've kind of illustrated why it's complicated because you can have a pointer to 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 some value, and there's just when we start reverse engineering the value of pointer or different pointers with Cheat Engine, we're basically going backwards in this hierarchy. When we were adding offsets, we were adding offsets in this video like so. So we're adding layers of indirection. When we start going backwards and finding pointers and getting back down to this address, what we're doing is we're going from the top level of this hierarchy down through the bottom. down to some address and some series of offsets relative to the start of this process's memory. So we're essentially going to be digging through multiple levels of pointers and removing offsets, and that's why this is important to understand.